All right, so here we go. Chapter 4, Section 1. We're talking about classifying triangles. We're going to classify them by their angle measure. That's these ones right here. And we're going to classify them by their side lengths. That's those right there. So those first ones, classifying by their angle measures. 4 ways to do it. First one is an acute triangle, right there at the beginning. Acute says that all 3 angles are going to be acute angles. An equiangular triangle, right there at the beginning, it's saying equal angles, so all 3 angles are equal. If their measures are equal, we say they're congruent. So we have 3 congruent acute angles. We'll talk about this more later, but a triangle has to have 180 degrees, and there's 3 angles, so to be an equiangular triangle, each of those 3 acute angles has to be 60 degrees. An obtuse triangle has to have 1 obtuse angle. Obtuse, again, is bigger than 90. This says only 1 obtuse. The other 2 angles are going to end up being acute. No matter what, the triangle is going to have at least 2 acute angles. And then a right triangle is probably the easiest one to see. It has a right angle, but just like here, even though it has 1 right angle, the other 2 will still be acute angles. So let's do a little bit of practice. We see 60, 60, and 60. All 3 angles are the same measure, so that makes this one an equiangular triangle. All 3 angle measures are equal, so equiangular. Right here we look at it, we have an acute, another acute, but the third one is definitely not an acute angle. It's bigger than 90, so this would be an obtuse triangle. Obtuse triangle is how we would classify that by its angle measures. Here we're going to have to take a little bit of liberty with some assumptions. It says the frame of this window design is made up of many triangles. They want us to classify triangle ADE. ADE is that triangle right there. We are going to assume, just because it really looks like it, that that is a right angle, so we will call this a right triangle. When we are doing these problems for real on a test and that kind of stuff, I will make sure that if it's supposed to be a right angle, it will be marked. Do not make that assumption on a test. Here we go. This one is good because they have the angles marked, so we don't have to make those assumptions. It says classify triangle XYZ, XYZ, so we're looking at the whole thing. I have a 50-degree angle here, 40-degree angle here. This angle, well, it's 40 and 50 together. 40 plus 50 is 90. So this angle is actually a right angle. So this is a right triangle. 90 degrees. It's a right triangle. The other 2 don't really matter too much. This one here, 40, 80, 60. All are less than 90. So we have an acute angle. Remember, an acute triangle. All 3 have to be acute to call it an acute triangle. So that's all of our examples with classifying by angle measures. So now let's classify by the side lengths. 3 different ways of doing this. If all 3 sides are congruent, we call it equilateral. There again is that equal, saying they're all the same. Equilateral triangles. Isosceles triangle is if at least 2 sides are congruent. And the scalene triangle is if all 3 are different lengths. You don't have any congruent sides. Just a reminder, right here, this tick mark, since all 3 have 1 on it, sides are all congruent. Here we have 2 and 2, so those 2 sides are congruent. That's how we mark sides being congruent. Again, back to this picture with the window, we're going to make some assumptions based on what it looks like. Most of the time we won't be doing that. Classify triangle ABC. ABC is this top little part right here. This side and this side certainly look like they're the same. We're going to make that assumption here, and I am going to call this an isosceles triangle. Again, I don't like this problem too much because that information really should be given to you. We should not be making assumptions like that. This problem is a lot better. It gives us all of the information that we need. It says point y is the midpoint of Vx, so y right here is halfway, which means that each of these two parts are congruent. This piece and this piece right here is congruent to right here. If the whole thing is 8.4, each one of these has to be half of that. So each one is 4.2, 4.2. They tell us WY right here. They tell us that's 3. And we want to classify VWY. VWY. It's just this half of it here. One side's 4.5, one side's 3, and one's 4.2. Since they're all different, we will call this a scalene triangle. If all three sides are different lengths, that makes it scalene. Here again, they tell us C is the midpoint of this side, so this piece here and this piece are congruent to each other. I marked them with 2 lines because each, right here we've already used 1. I don't want to mark it with only 1 and get those confused because I don't know if those are congruent to each other yet. Each one's half of 3.4. 3.4 divided by 2 is 1.7. 1.7. So, I want to classify triangle ABC. A to B to C is this half right here. I have 1.7 on this side, 1.2 here. This mark means it's the same, so it's also 1.2. These two are the same. This one's different, so it's an isosceles triangle. 2 sides are the same, third one's not. Isosceles. Right here, find the measure of the sides of isosceles triangle KLM. So they tell us it's isosceles. 2 sides are the same, and it says base KL. The base, that means the one that is not the same. That's what the base of the isosceles triangle is that third side that's not the same as the others. So if KL is our base, that means this side and this side are congruent, or they're equal. So we can do 4D minus 13 equals 12 minus D. And now we just need to solve our algebra. Add D to both sides. 5D minus 13 equals 12. Add 13 to both sides. 5D equals 25. Divide by 5. And we have the fact that D is equal to 5. Now this doesn't just ask me to find D, it wants me to find the measures of all of the sides. So I need to take 5 and plug it in. So I can say KL, the measure of KL, or distance KL, is 5 plus 6. That gives me 11. Length, or distance, KM, K to M, is 4 times 5. That's 20. 20 minus 13 is 7. And from L to M, LM, is 12 minus 5 is also 7. I like the fact that KM and LM came out to the same number because, again, this is an isosceles triangle and those two need to be the same. One more problem here. Find x and the measure of each side in equilateral. So this means all 3 sides are the same. So to start out, I'm just going to pick any 2, doesn't really matter which ones, and set them equal to each other. 6x minus 8 equals 7 plus x, and solve it out. Subtract x, get 5x minus 8 is equal to 7. Add 8 to both sides, and I get 5x equals 15. Divide by 5, and I have x is 3. So a and b are out right away because x is 3. I take 3 and I plug it in. 6 times 3 is 18. 18 minus 8 is 10. Plug 3 in here. 7 plus 3 is 10. I like it. 13 minus 3 is 10. All 3 of them come out to 10, which is good because it's equilateral. So x is 3 and all sides are 10. So the answer is C. Alright, this last slide, just your homework assignment. You can pause it here and copy it down, or you can find it on Canvas. Have a great day.